Hi everyone, welcome back. We're going to start something new in this chapter again related to acidity and basicity. We will start talking about the qualitative analysis of relative acidity. Now, that's a very important term. If I have one acid given to me, I don't think I can tell, like for organic acids especially, we cannot claim them to be like strong acids or weak acids. It's always like a relative terminology. So we can, if we have two or three acids, then we can predict or determine better word which acid is stronger and which one's weaker. So that is what we're going to be doing here. So I will sort of introduce you to the process here, but relative acidity is key. So let's pick two acids, HA, or let's start with just one acid, HA, uh, and this acid is going to give us, let's just use water as a base. This acid is going to react with water and give us hydronium ions and the conjugate base. So this is the acid and this is the conjugate base. Okay. Now going back to how we define a strong acid or what our understanding of an acid is. Okay. Ha is an acid, that means it generates or donates protons. Now, if Ha is a strong acid, that would mean that it would generate a lot of protons in solution or donate a lot of protons or be able to donate protons more easily compared to something else. That is what we're saying here. Okay. Now, when Ha loses its proton, it becomes A minus, the conjugate base. So if A minus, okay, if A minus is unstable, it is something that cannot stabilize that negative charge that has been generated. If A minus is unstable, then what A minus would like to do is it would like to grab the proton back from hydronium ion and go back to Ha. It would just like to go back because it's not happy, it's unstable. On the contrary, if A minus is stable relative to something else, okay, it is pretty, not pretty, but it is like relatively happy in this new uh, form that it has to exist with a negative charge, then it would be okay with not grabbing that proton. And that means Ha can go become A minus, or it can lose the proton at the same time. Okay, so I'll write this down. So what I'm trying to say here is uh, the strength of an acid depends on the stability of its conjugate base. Okay, stability. That's the key here. The conjugate base has to be stable. Okay, if the conjugate base is stable, then the acid will be stronger. And if the conjugate base is not stable, and when it is not stable meaning again unstable, or now since we're talking about relative terms here, I think they should be read more as if the conjugate base is more stable, then the acid would be stronger. And if the conjugate base is instead of less, instead of not, I'm going to make it less stable, then the acid will be weaker. Okay, so the stability of the conjugate base determines the strength of the acid. If the conjugate base is more stable, then the acid is going to be stronger. If the conjugate base is weaker, or if the conjugate base is less stable, then the acid is going to be weaker. So let's introduce another acid here. Okay. If there's another acid, HB, which reacts with water to give, again, there's equilibrium here. So if it reacts with water to give B minus as a conjugate base, and if I have to determine which of these acids is stronger, what I'm going to do is I'm going to ignore this, and instead I'm going to look at the two conjugate bases, and I will evaluate their relative stability. My job would be to evaluate which of these is more stable. And once I have determined the conjugate base which is more stable, that would tell me which acid is the stronger acid. So example, in this particular case, if my analysis says that B minus is a more stable conjugate base than A minus, what that would mean is HB is a stronger acid compared to HA. Okay, so when we qualitatively analyze acid strength or acidity, the analysis is always based on the stability of the conjugate base, okay, of the conjugate base. Now, how do we analyze the stability? Okay, so factors that affect stability of the conjugate base. We will look at these in subsequent videos, but the four factors that we are going to consider are the atom or element effects. We will talk about resonance effects, inductive effects, and orbital or hybridization effects. So these are the four factors that we will use to analyze the stability of conjugate bases, and based on that analysis, we'll be able to predict a stronger acid of a group. Okay, from a group of acids, we'll be able to predict which one is the stronger acid.